Hello everyone, my name is Anvita Bansal and we are back with another lecture from your SDE sheet. And the problem that we are going to solve today is merge two sorted arrays. So let me just check if you can see my screen quickly. Second. Yes, I think. Okay, so moving on to the problem, let's have a look. I think. Okay. So merge without extra space. What does this question say? It gives you two sorted arrays, ARR1 and ARR2, of sizes n and m in non-decreasing order, that is, they are in sorted order. Merge them in sorted order without using any extra space. Modify ARR1 so that it contains the first n elements and modify ARR2 so that it contains the last m elements. So the question says that you have two individual sorted arrays, okay, and you have to sort them in such a way. If it was an entire array, just imagine all the elements of ARR1 and ARR2, and if they all together form an array, so what would be the order of elements if they were sorted? So those elements, the first m, if let's say the length of ARR1 is n, so the first n elements should be placed in ARR1 and the remaining elements of length m should be placed in ARR2 if all together elements of ARR1 and ARR2 in the sorted order. Okay, so let's move to the whiteboard and understand how we can solve this problem. Let's have a look. Let me take this test case. Okay, so let's say this is the test case given to you. Now, what would be the order of elements if all the elements from ARR1 and ARR2 are in the sorted order? So we have to understand that. Okay, how can we solve it? Just a second. Fine. Now let's understand it in this way. What is the first approach that might come to your mind? The very first or intuitive thought that might come to your mind before solving this problem can be, why not take an extra space, some extra space, let's say ARR, whose length will be equal to, let's say the length of this array is n, the length of this array is m. So we will take an array ARR whose length will be n plus m, right? This is something that might come to your mind immediately when you see this problem, right? So let me just draw that array of length n plus m and let's see how would it look like. What is n here? N is 4 and m is 5. So 4 plus 5 total 9. 9 should be the length of your array that you are going to draw. So if I take 1, 2, let me also 3, 4, 5, 6, 7, 8 and 9. Okay, if I were to index it, it will be 0, 1, 2, 3, 4, 5, 6, 7 and 8, right? So tell me one thing, consider these, all of these elements as the elements that you want to sort. So in the sorted order, what would they look like? Or how can you sort them? Let's also apply that approach that would be the intuitive one. If you think of this problem, we have also used this approach in our previous lectures of arrays. So what can that be? Put one pointer I, let's say here, and j here. Compare I and j. If ARR of I is less than ARR of j, what should happen? Your, let's say this is your ARR. Okay, then this is ARR1, this is ARR2. Let it be ARR2, and this, let this be ARR. Okay, I'm talking about the brute force approach right now. So you can take two pointers, one start at the starting index of your ARR1, other one at the starting index of your ARR2. Then you compare. The smaller one should go into your ARR, right? So if we see ARR2 is smaller, so it should come here and J should increment by 1. Then what you should do in this condition, ARR of, let's say, K, okay, another pointer we can take, K, should be equal, means that place should be filled with the smaller value, that is ARR1 of I, right? Else, else if the other one is smaller, then ARR of K should be stored with the other smaller value, which is ARR of 2. If this is the case, you also increment the count of I. And in this case, if you come to the else part, you increment the count of J. And this happens till while your I is less than what? Its last, the length of that array over which I am iterating. So what is the length of ARR1? And apparently your J should also be less than the length of that array over which you are iterating. Till this, you keep on doing it. Now you will think we can keep a separate counter for, let's say, K0, and at every index we will do K plus plus. That thing we can do, or you can also handle it with, let's say, J. You can also handle it with J, ARR of 0. If it's J is at 0, so you can also write J here. If we are talking about I, you can write I here, whatever indexing we are doing. But I think that wouldn't work. So let's keep a separate pointer for your separate array. Okay, fine. Now, once you are done with this iteration, let's compare it. First, we got 0 here, then I is at 1, J is at 2, which is smaller, 1. So you put 1 here and move your I pointer ahead. Okay, K is right now at 2. Fine. Which is a smaller one? J is smaller one. So you put that value here and move it to the next value, next index. Compare I with J. I is smaller, so I moves to the next index. 5 and 6, 5 is smaller. I moves to the next index. 7 and 6, 6 is smaller. J moves to the next index. Now you compare 7 with 8. 7 is smaller. I moves to the next index, and I comes out of bounds right now. This condition now fails. It is not less than n. So what will happen? This means that when you come out of the loop, either of the arrays we have already iterated. You get this point? Whenever we come out of the loop, that means either of the array has been completely iterated and one of them is yet to be filled in your array, or there might be a possibility that both are of same length. Then there is no element left to be put into this ARR. So we will check if your I is not equal to n, right? Or it is less than n. You can check that way also. So instead of doing this, you can also do while I is less than n. If, let's say, you are still left with elements in ARR1, then what you have to do, ARR of K should be stored with ARR1 of I and I plus plus, right? Otherwise, while another loop, J is less than M. See, if I is already equal to N, we will never go into this while loop, right? So you don't have to worry about that. And in the other case also, if J is already equal to M, that is, there are no elements in ARR2, then also it will never hit this condition and ARR of, and you don't have to worry about. So finally, by the end, now when I am at this out of this while loop, I will check I is already equal, I is not less than n, I is equal to n. So I will not come into this loop. I'll check for this loop. J is less than m. Yes, my J is still left to be hit, left to hit m. So I will check ARR of K should be filled with ARR2 of J, that is 8, and then the next one is 9, and then J plus plus J also reaches M, and we come out of this. In this way, the array that you get now is ARR, and that is completely sorted. But finally, what you have to do, that in your ARR1, you have to fill first how many elements? N elements from ARR to ARR1. So you will take another for loop starting from 0 to n, right? You will iterate over ARR and put ARR1 of I as ARR of I, right? Then in the other for loop, for I is equal to how much? See, 0 to n was 4. So last index that we would have, this is exclusive, okay? So basically it is going till n minus 1th index. So till this index, it has already filled in ARR1. In ARR1, now ARR1 looks like this, 0, 1, 2, and 3. That's what we wanted in ARR1, right? Now we want to fill ARR2 with the remaining elements that will be from 5 till 9, right? 5, 6, 7, 8, and 9. That is what we want to do. Let me just erase it and do it for you again. So what kind of result do we want? Once we are there with this array, this is the brute force approach I am yet explaining. So once you have filled this ARR, you have taken some extra space already. Still, you have not got your answer, because your answer should look something like this. You have an array ARR1, which should have the first n elements. So it should ideally contain, in the sorted order, 0, 1, 2, and 3. All the first n elements from the sorted ARR, and your ARR2 should contain the remaining m number of elements in the sorted order, that will be 5, 6, 7, 8, and 9. So your ARR1 and ARR2 should look like this by the end of all the iterations, or by the end of entire coding. So in order to make ARR1, ARR2 in this order, what can we do? Now start your iteration from I0 till last index inclusive n minus 1. You are going to fill ARR1 of I with what? ARR1 of I will be filled with ARR of I, right? Or you can do one thing, just one iteration would be needed. And from, we are iterating from 0th index till last index, that is k. Let's say the length of this array is k for time being, or m plus n, whatsoever you want to do. Basically, I'm iterating from 0 to till 8th index, right? So let it be k. So ARR of I should be actually, for, if this is k, if this is I, so let me do one thing. ARR1 of I should be equal to ARR of I, right? And let it be from I equal to 0 to n minus 1 inclusive. Then there is another loop starting from I equal to what? N till what? N plus m minus 1th index, right? So that will be 8. So ARR2 of, now what? I is your n, that is I is at 4 index, but ARR2 starts at 0th index. So how can you handle this thing? So you can make it I minus n. Your n is what? 4. So I is 4. 4 minus 4 is 0. That can be made equal to ARR of your I. So if you check, when in ARR2, I is currently 4. Now when I is 5. So 5 minus 4 is 1. So this index should be filled with ARR of I is 5. Similarly, when your I is at 6th index, so 6 minus 4 is 2. So ARR of 2, which is this index, will be filled with ARR of I was 6. So 7. So that's how you can handle it. Now coming on to time complexity. Time complexity of this approach. What are you doing? First of all, you are storing all the elements from ARR1 to this new array ARR. So that takes total O n of time. Then all the elements from ARR2 of length m, again you are doing the same thing for ARR2 also. And then from this ARR, you again traversing to this ARR and putting all the elements to this. So that is something like O of n plus m. So big O of n plus m is what we can say is the time complexity, or not n plus m, it is also on plus om, because we have put in this, in our explanation, we have taken two separate for loops. Once it is iterating over the length of n, other time it is iterating over the length of m. So basically two big O of n plus twice of big O of n. So we can say big O of n plus big O of m is the time complexity. What is about space complexity. If we talk about space complexity, you have taken one array of O(n plus m) space. So this is the space complexity. Now talking about, and since this was a two pointers approach, and it took you almost two times big O of n plus big O of m of time complexity. Now coming on to, if you look at your problem, it says, can you solve it without using any extra space? Can we do it in place, or can we do something such that we do not have to take any extra space? So now we will be discussing that approach. Okay, so let's have a look. Without using any extra space, how can we solve this problem? If I look at my problem statement again, let me take it. Okay, so let's use the same test case. Okay, this is your test case, right? How can we do it without any extra space? That is the challenge in this problem. So see, again, we will be using a two-pointer approach, and this is also going to be very simple only once you understand. So what are we going to do in this problem? We are going to make use of this fact that both arrays are sorted. Okay. So if you check this first ARR1, this is 1, this is 3, this is 5, and this is 7. If I check another array, this is 0, this is 2, 6, 8, and 9, right? If I talk about 3, 0, 1, 2, 3, 4. Let me take my one pointer, let's say I, which is pointing to the last element of ARR1, and pointer j, which is pointing at the starting index of ARR2. This is your ARR2. Now, why am I doing this? See, one thing is for sure, in the entire sorted order of all these elements, the first smaller four smaller elements should be in this array, and the other remaining elements, which will be greater than the elements present in ARR1, should be in ARR2. So can I make some decisions based on this fact that if I'm at the last position in my ARR1 and I compare with the first index in ARR2, one thing is for sure that this value is the biggest in ARR1 and this value is smallest in the ARR2 because both of them are in the sorted order. If I find this value and if I check the biggest value of ARR1, if I compare largest value of ARR1 with the smallest of ARR2, and that largest value, if that largest value is greater than the smallest value of ARR2, I can say one thing for sure, that this element should not be present in ARR1 if it was in sorted order. You getting this thing? If the largest element of ARR1 is greater than the smallest element of ARR2, that should not take place in ARR1. That should ideally go to ARR2. So let's do one thing. Let's swap them. So if I swap them, how will they look like now? You just need to understand this iteration and everything will be sorted for this approach now. This is a better approach that we are going to discuss. So now the array looks something like this: 1, 3, 5, and this will be 0. And here your array would be, this value is 7, 2, 6, 8, and 9, right? So your I pointer comes one step back, that is it decrements its count, and j comes one step ahead. Okay, now compare I with j again. So you know one thing for sure, that this value right now is the greatest value of your ARR1, and this value, this is 2, this is 7. This value is the smallest value of your ARR2. Again, you check the same thing. If this value comes out to be greater than this value, which it is, so you should swap it. So after swapping, how will it look like? After swapping, now it will look like this. See, when you swap it, what will be the condition now? This is 1, this is 3, your 5 is swapped with 2, 2, because this is telling me that all the smaller elements, all the first n smaller elements should be in ARR1. I'm just trying to do that. So 2 0, and here what I will get now, this is 7, 2 is swapped with 5, 6, 8 and 9. Is that fine? Now where is your pointer? Your pointer decrements, I comes here and j goes here, right? Okay, compare 3 with 6. Now the largest of ARR1 would be this value only, and the smallest of ARR2 would be this value only. Okay, of original ARR2. Don't confuse it with these values. Original I'm talking about, in this originally. Okay. So this is the smallest of your original ARR2, and this is the greatest of your original ARR1. Now if I find this value to be smaller than this value, that means 3 is in its right array, right? This means that 3, this is the position, this is the index at which I am finding that ARR1 is actually less than your ARR2 of j. If that is the case, that means that the element itself is in the right array. It's in the right array, right? You don't need to swap. It means this is the point that where we should stop our iteration, and now we have got array ARR1 which contains all the elements that should be present in ARR1 after sorting, and ARR2 contains all the elements that should be present in ARR2 after sorting. But these are not in the sorted order, not in the sorted order. So now the next thing is, once we have those lot of elements, those number of elements that have to be in ARR1 and ARR2 respectively, now we can simply use our inbuilt sorting method, ARR arrays.sort method, and we will sort each one of them separately, ARR1 and ARR2, and that's how your final array will look like this. It will be 0, 1, 2, 3, and this will be 5, 6, 7, 8, and 9. I hope this thing is clear. So what we were doing, we were just making use of this fact that both the individual arrays are sorted, and I am comparing the biggest of ARR1 with the smallest of ARR2. If this is greater than this value, then it will get swapped so that I can make sure that all the smaller elements are in the ARR1 and all the bigger elements in ARR2. That is my aim, right? So once I find this condition to be not true, that means ARR1 of I is less than ARR2 of j. That means that is the position I need to stop, because I've already gotten all the. See, why did I stop here? Because one thing is for sure, if I go even behind, let's say I decrement the count of I, if I found this element to be smaller than ARR2, then all the elements behind this index would be smaller only. And if this element came out to be smaller than this value, so whichever element I take behind I, whether I do I minus 1, I minus 2, I minus whatsoever, all of these elements will be smaller. You getting this point? Because this ARR1 is sorted till here. As in when we are decrementing the count of I from 0th index till ith index, it is already in sorted order. So at whichever position I get an element which is smaller than that element ARR2j, that means all the elements behind that are going to be smaller. That is why I stop my iteration there and I sort them individually and I get the correct array which I want, right? So time complexity. What are we doing in this case? Are we taking any extra space? That is the best thing we have done, because that was the demand of the question. Otherwise, coming on to time complexity, so what we did was, we are taking 2 pointers and we are actually running a loop which is checking I. We started from n minus 1 at the index, so I should be greater than equal to 0 and your j should be less than m. So as and when one of them exhausts its length, I can say that my iteration will go at max of O big O of max of n comma m, means whichever length is greater, whichever, sorry, the minimum one. See, the minimum one will make me come out of the loop. Let's say if n is 3 and n is 4, m is 5. So as and when I reach my I index at 4, I will come out of the loop. So whichever is minimum, it will take big O of min of n comma m, right? Okay. And then what are we doing? So this is what we are doing. And it comes out of the loop only when we encounter this condition, right? After that, we are taking arrays dot sort two times, once for ARR1, once for ARR2. So two time, not two times, big O of, let me write it nicely. Look here again, talking about time complexity. So you are running it till starting your I from here, j from here, whichever reaches the, in the worst case, whichever reaches the entire length of its array, that is the time it will take. So minimum of n comma m, big O of minimum of n plus m, plus n log n is the time which arrays dot sort takes to sort the array, plus we are doing the same thing for another array also, ARR2 m log m. So this is the time complexity that is taking place here, right? So if I were to take a bigger value, it will be something like this, n log n plus m log n is what you can consider to be the time complexity. And it will be plus big O of n or m, which will be lesser than this value only. So we can predominantly take this as a time complexity. And coming on to space complexity, there is no space that we have taken extra in this problem. So let's have a look and solve this problem. If you have any doubt in explanation, you can ask me. Okay, just a second. Fine, let's start this problem. So let me check if you guys have understood, or if you have any doubts, you can ask me. Okay. We are going to solve it with the optimal approach that we just discussed without using any extra space. So let's take and I starting at the end of the ARR1, that is n minus 1. You can see n is the length of ARR1. Okay. You can see that in the question. Then int j is at 0 while I is less than, I is greater than equal to 0 and your j is less than what, m. What are you doing? You are checking if ARR1 of I, if that value is greater than ARR2 of j, you are swapping. Let's swap them using a third variable, ARR1 of I, ARR2 of j, 1 of I, then ARR1 of I is temp. I think I did something wrong or what? Temp ARR1. Fine. Okay. Then what? Then you are decrementing the count of I and incrementing the count of j. If this is the case, you are doing all of these stuffs. If this condition fails, that is this condition which we saw here. If this condition fails and we come at this condition, right, then what? Then you know that you have reached at the right position of the element and you do not need any more swaps. So you just come out of the loop. We do not want to go into the loop further, right? And when you come out of the loop, what you want? You just want to sort your arrays. That is all. Let's check. Okay, so this is of type long, so let me take it long. And this is all about this problem. So I hope you have understood this. If you have any doubts, you can ask me. You can have a look at the code. So what we discussed two approaches. The one was the brute force approach that was quite intuitive. Even this approach is intuitive once if you know how you can avoid the use of extra space. There is also one more optimal approach which actually takes this amount of time which they have mentioned, expected time complexity. So that can also be taken, and that approach you use gap method. That's not, I would not say that's very intuitive approach, but yeah, it's a good approach. It's this one is easier than that approach, so it can be intuitive as well. I think if you have any doubt you can ask me, otherwise we can wrap it up. Fine everyone, then that's about today. Let's see you all in tomorrow's lecture. Thank you everyone. Bye bye.